Hello, I've told you in previous video that there will be further reviews, and this is part 2. The purpose of this video is to recall the notions we've learned in your mind, so don't be worried even if you don't get the questions. However, it is a problem if you leave the concepts behind and don't catch up, so it is crucial that you review the ideas once more if you don't get it. Let's begin. The answer to the question is number 3. It is skewed to the left. So if you see the graph here, you see the data are more concentrated to the right side, to the number 4 and 5 and 3 mostly, while there are much less data in 0, 1, and 2. Therefore, it is not bell-shaped and it is not skewed to the right. If it's skewed to the right, it means that most of the data is concentrated in 0, 1, 2. So the answer to the question is that it is skewed to the left. The spread is not from 0 to 50. The spread is from 3 to 50, which makes the range 47. That is the correct answer. Next question. Find the outlier of the following set of numbers: 1, 6, 7, 7, 8, 10, 11, 16, and 21. Now, I've added this picture just to give you an idea how to solve this problem, and I think I've already gave you the answer if I gave you this already. So, I hope you guys remember in the previous video I have said that the interquartile range is Q3 minus Q1, and you need to get the value of 1.5 Q3 minus Q1. And here, okay, this value should be Q3 plus 1.5. This is my error. Remind that this is a 1.5 Q3 plus 1.5 to find the value of the outlier. So if we try to do this, what we have to do is we need to first find the interquartile range, the first and the third quartile. So our set of data were 1, 6, 7, 7, 8, 10, 11, 16, and 21. That is total 9 data we have. So we first need to divide this 9 by 4, which is 2.25, and then we multiply this by 3 to 6.75. When we get this kind of decimal values, if we don't get an integer or a natural number, then what we have to do is we always round it up. So the first quartile is the third number, and the third quartile is the seventh number. What's the third number? The third number is 7. And what's the seventh number, which is 11. So we use the equation Q3 minus Q1, which equals 4, and then we multiply this by 1.5, which equals 6, meaning from the mean, we have to either, from the first and the third quartile, we have to either minus or add. Our first quartile was 7, so 7 minus 6 equals 1. And our third quartile was 11. So 11 plus 6 equals 17. So any value that is smaller than 1 or bigger than 17 is an outlier. 1 is safe in the range, 16 is safe in the range, 21 isn't. So the answer to our question is 21 is the outlier. Next question, the z-score. So first question says state the equation of getting the z-score. Second question says a mean is 6 and the standard deviation is 1.5. Find the z-score of the value 8.3. And the third question looks similar to the second question. A z-score is 5 and the mean is 4 and the standard deviation is 2. Find the missing value. So the 2 and 3 are basically similar questions. They just have different missing value. Let's answer the question. What's the equation of the z-score? I hope you guys remember. It is z equals x minus mean over the standard deviation. And second and third question, we just have to apply the numbers. Mean is 6, 1.5 standard deviation, 8.3 is the x. 8.3 minus 6 over 1.5 equals 1.53. The third question is we have to kind of manipulate the first equation, the z-score equation. So what we do is we're missing the value of x, so we just want to leave x alone. So what we do is we multiply standard deviation to both sides, and then we add the value of mean to both sides, which cancels out and leaves x only on the right side. And the equation becomes z multiplied by standard deviation plus the mean equals x. 4 times 2 plus 4 equals 12. The z-score was 5, mean was 4, and the standard deviation was 2. 4 times 2 plus 4 equals 12. X equals 12. The last question is about the empirical rule. The first question says, define empirical rule. Second question says, one value is known to be within 95% of the total data. What is the furthest standard deviation the value could be away from the mean? And the third question says, it is said that in city A, people consume about 90 million gallons of water per month, and the standard deviation is 12 million gallons. Assume the data is spread into bell-shaped form, so it is spread widely and fairly, and use the empirical rule to extract further information. Let's answer the questions. The definition of the empirical rule is that it is also known as 68, 95, 99.7 rule, which can be applied to asymmetrical data. It says that values within one standard deviation from the mean are 68% of the total data, 2 standard deviations are 95%, and within 3 standard deviations are 99.7% of the total data. That is the empirical rule. So we just answered the second question. If a value is known to be within 95% of the total, it can be 2 standard deviations within away from the mean. Third question. So we know that people who consume from 78 million gallons to 102 million gallons of water are 68% of the total. And people within 56 million gallons of water to 114 million gallons of water are within the 95% of the total population. And lastly, people who consume from 44 million gallons of water to 126 million gallons of water are 99.7% of the total population. That is the answer. And we have ended the review part 2. Congratulations!